Hello everybody, my name is Dimitri Stiliadis. I'm the CTO and co-founder of Nuage Networks. I'm really happy to have you here today, and we're gonna chat a little bit about some updates, some new things coming out of Nuage and how they evolve and how they relate, let's say, to data center networking in general. As you guys know, we have talked a couple of times, we have done a couple of these tech field days. We have presented a lot of the Nuage capabilities. Nuage is delivering a virtual network solution, a virtualized networking solution, mainly targeted in the data center. We also recently announced an expansion, if you want, of the product addressing the branch space. And I'm really excited today because today we are announcing yet another component of our solution that I think is fundamental in actually operationalizing virtual networks and data center networks in general. This morning it was actually very good. We heard the keynote at ONUG from Andrea Crockford there, and I was laughing because he was using pretty much a little bit my slide here. So he did the perfect introduction, right? He was talking about IT delivery, and it's the velocity of IT delivery that really matters right now for a CIO and for the IT organization in general, right? It's how can we transfer from business requirements, deliver the product all the way to a customers, and get the feedback from the customers and go through this infinite loop. And the question is, how fast can we make this IT delivery? And of course, you will ask, well, what does network have to do with this? Well, the network is a big part of this IT delivery equation, if you want, or of this cycle. We want to be able to deploy applications fast. We want to be able to design applications fast. We want to be able to operate applications and get feedback out of the applications. And so it's very important to optimize this loop. And the reason, to a certain extent, we created Nuage Networks is to try to get the network out of the way of the IT service delivery loop. That's our goal. So in the first part, if you want, of Nuage Networks, we did over the last 2 years a couple of things. We created abstractions. We created a policy-based declarative type of mechanism for the application guys to describe their applications. So we try to make it as easy as possible for an application developer to describe what they need from the network without necessarily understanding, if you want, all the details of the network, right? Create all this level of abstractions. From a deployment standpoint, we did a lot of the things that make the CIOs a little bit more comfortable. For example, deploy security and policy management primitives over there that will allow the IT department or the security department to create and define their policies while the application guys can continue doing their job, right? So this was all part of us trying to optimize dev and test and deployment. What happened though is, and we have several customers who are deploying overlay networks. It became very apparent that there was a group, if you want, or a part of the organization that was underrepresented in all this equation. And that's the operations people. And the operations people would ask every time the question, okay, this is all good, application guys are happy, the security guys or the policy guys are happy. What happens on day 2? What happens on day 3, on day 4? This thing is running. How can I get the same visibility and control that I need in order to be able to maintain the applications and the network running at top capacity? So what we set out to do is we set out to solve this problem as well. And that is part of what I'm going to talk today about, and what we are going to a certain extent, bring up and talk about in more detail is how can we provide the tool sets that will allow the operationalization now of the network. They will allow operations to take over and understand when all these virtual networks are happening, what is happening, where is the congestion points, what are the failure points, what is the correlation between failure in the physical layer and the overlay layer, or vice versa, right? What failures or what actions in the network virtualization layer are actually affecting the physical layer. So our next part of, if you want, on this journey that we started with Nuage is to actually figure out exactly this particular area. So when we are talking about Nuage, actually, some of the principles, and I'm showing this slide pretty much every time I'm talking about Nuage, some of the principles that drive the Nuage technology is the belief that we have to push as much complexity as we can at the edges, right? This is the internet principle, is the end-to-end principle that has allowed the internet to scale, and the realization also that in none of these cases that we are talking about deployments, we are talking about single networks. We are always talking about networks of networks. Even when we are talking about a data center, we are never talking about an island. We are talking about a data center that has to interface with several other networks, potentially multiple availability zones, and so on. So when we are seeing it from this perspective, right, and when somebody sees these pictures, we are always representing, if you want, the core of the network or the physical layer or the foundation, if you want, the physical network as a nice big cloud. And this gives you a little bit the comfy feeling, right? This is a nice fluffy cloud, all the kinds of things are happening there. The reality is, though, we need to see underneath this cloud what is happening, and that is the purpose of understanding how to operationalize these networks, is what is actually underneath these clouds, right? So when we see Nuage, right, and an overlay deployment, we assume that we have a data center. The data center has top-of-rack switches, some core network. Potentially, we can have a second data center, second availability zone with top-of-rack switches and another core network. We might have a data center interconnect network. And with our offer, where we are talking about branch offices, we are actually extending all these overlays that we are building within and across data center networks all the way to the branch offices, right? Now, the reality is that implementing these networks involves a whole bunch of physical topology underneath, whether this is routers, switches, right, within the core network, within the data center network, potentially multiple autonomous systems happening when we are interconnecting data centers, and so on. So now we are considering how can we view this underlay network, and how can we correlate what is happening in the overlay in the service world with this underlay network. Now, in reality, this is not a new problem, right? If we think about an MPLS network, it's pretty much something like that. There is the MPLS service layer running on top of an IP infrastructure, if you want. People have encountered these problems before, and they have solved them. Unfortunately, these solutions haven't made it to the data center. So what we actually did in Nuage is we got a lot of the ideas and the concepts on these solutions that scale large service provider networks and provide this correlation between services and actual physical topology, and we're bringing them in, if you want, in the data center and enterprise space. The question we are trying to ask is actually very simple. If I have a failure somewhere here and I lose one of my routers, what happens? What services are affected? How are services going around this router, if they can go around this router? How are my SLAs affected? And at the same time that we are doing this, we can even start asking the opposite questions. If I actually want to bring this router down, and I want to bring this router down because I need to do a maintenance function or whatever, how do I bring this router down? What services am I going to affect if I bring this router down? How am I going to affect my customers out of this? So there are several alternatives on trying to figure out this that have been proposed before. There is the hardware-centric alternative, and we are in ONUG, that's the anti-ONUG, if you want, alternative, says you have to buy your hardware, your software, everybody from me, and then I can solve this problem because I'm going to use my own tools to do that. There is the server-centric alternative, a lot that we are hearing in network virtualization, that is essentially, let's largely ignore the problem and let's just state that, well, we have an ECMP fabric in the data center. We don't need to worry about any failures on the underlay, just ignore about it. I call this the marketing machine approach. And then there is the open networking approach. What I believe is possible is, I believe it's possible to use standard protocols and open interfaces to actually solve this correlation problem between the underlay and an overlay without really either locking yourself in a proprietary solution or locking yourself in a particular vendor. And I believe this is possible because not only it has been done before, but because all the switches that I know of support, and all the physical infrastructure that I know of support very basic primitives that we can use to actually do this. And the important thing is we don't need to wait, right? We can say we need for the world to transform to SDN before we can do that. We don't need to wait. I think we can do a lot of this stuff with what we have in our capabilities today. So how do we do it, right? And the solution is actually very simple, at least conceptually is very simple. The solution consists essentially of two components. The one component we have is what we call the route monitor, or a monitor capability here, that essentially sits as part of the physical network. The route monitor uses standard techniques, that is routing protocols in other words, to peer with a physical network, whether it's the backbone or whether it's the data center network. Here the picture is a little bit misrepresenting it maybe, but essentially it can peer with a data center network or a backbone network, and the route monitor can listen constantly to all the routing protocol updates and reconstruct a complete graph of the physical topology of the network, at least the layer 3 topology, right? And I'm being very honest on that. So it can reconstruct the layer 3 topology. Within a data center environment, it can reconstruct the complete physical topology. Very often within a backbone environment, it will not be able to reconstruct completely the whole backbone. It will be able to reconstruct though the AS paths that you have to take, right? Because a lot of service providers are gonna try to hide, if you want, what they have in their backbone network, but they cannot hide the AS paths, right? Because every time you start peering or going to a peering situation, this has to be advertised. So the route monitor is going to create a physical topology of the backbone is going to be at the AS level, within the data center is going to be exactly precise at the top of rack level and core switch level, right?
So that would mean you would have to have, in the case of OSPF, your IGP would present the full database and you could listen to that, so you would get a complete map. Correct. But in the case of BGP,
you either run IBGP that you get whatever, or you run eBGP that you get the AS paths.
You get the AS paths. So you're not going to see into other people's autonomous systems. Right. So what happens inside of, if you've got 4 or 5 autonomous systems that you're crossing, you're not going to see what's inside of those, right, which is the way BGP works, of course, right? So that's not, but you're going to have data about the path. You're going to know the AS path and say this AS path works this. You're going to be able to calculate from the BGP data some sort of map or network, a graph of the network, and be able to path it.
Essentially, the graph is very similar to that picture, right? You will see clouds, and you will see how the clouds connect together, right? The complete BGP topology, if you want.
So because you're then listening to the OSPF database or listening to the BGP updates or getting them from the iBGP peering process, then you're getting the EGP announcements into the, as long as you don't, I guess it also means you can't filter out. You'd have to see the whole.
You don't filter out, right? You get the whole thing. You absorb the whole route table there.
You want as much of the data as possible to get more information. So there's some. You need to be a little bit careful in your design. But what I'm saying is, if you start to see route flaps in the BGP, or if you see OSPF state changes, then you know something's happening in the underlay.
Exactly, right? And I'm going to come to that. And it's very important that anytime you see this route flapping, you see routes removed, routes added, you need to correlate them. And I'm going to go in my next level here now. So the layer 3 topology is actually relatively simple and relatively standard, right? We're not actually the first to do that or propose that. A lot of people have done that before. Now, especially on the data center, there is the second part that says that I have the top of rack switch, I have a bunch of servers underneath. I need to figure out which server is connected to which port, right? And this is not really part of the layer 3 topology because south of the top of rack switch is a layer 2 network, right? So I need to figure out which server is connected to which port. So we need to find this information as well. And now, the way to find this information, there is no magic bullet. You use whatever the vendors of the physical switches are going to give you, right? So probably every vendor that I have seen has a basic SNMP MIB that I can recover the basic MIB2 data, right? So I can use SNMP to figure out all the interfaces, figure out which ports are up and down, which servers are attached behind which each port, just by using basic SNMP. More advanced switches potentially offer to me better APIs, if you want, than SNMP, but I don't want to sneeze away on SNMP because it is there. So if it is there, I'm going to use it and deal with that, right? I'm not going to wait for magic to happen before I can move on with solving the problem, right? Yes.
Whichever happens first.
Whatever, right? It's a southbound API, right? But basically, this monitor manages all the layer 3 topology, and by using the southbound API towards the top of rack switches, recovers all the layer 2 information it can recover, as well as interface status, up-down interface type of events. And now it correlates that, it builds a big graph, right? Now, once we have this graph in our hands, we can overlay on this graph the topology of the virtual switches, because we have the other component. We have the Nuage traditional component that says, oh, this virtual switch is running on this server. Oh, this server is connected to this port of this top of rack switch. So now I have the whole virtual switch topology, if you want. Once I have the virtual switch topology, I know on the Nuage component, on the VSD component, on the network virtualization component, which VMs are actually attached to which virtual switch, or which VMs are attached to which overlay network. And now I can overlay, I can correlate the two. I can correlate the physical with the virtual infrastructure, and I can get a complete topology that this virtual service is running on on these physical nodes and vice versa, right? Or which virtual services are running on which nodes. So now out of this, having all this information, right, it's a lot of information. Now, what we do after that is every event that is happening, every route update, every BGP flap, every interface update, everything is logged, right, through this information. And what we do in our correlation engine is we start correlating this information. So we are able to detect that this port went down. Because this port went down, this route was withdrawn. Because this route was withdrawn, this vSwitch is not reachable anymore from the other vSwitch. Because this vSwitch was not reachable, these VMs are affected, therefore service on these VMs is going down. All this correlation is happening automatically by the tool, and it can happen back in time. And I'll show you some of the use cases we are trying to address that are important for an operations guy's perspective, right? The operations guy gets the call last night from 2 to 3 a.m. my VM was not working. What happened? Go figure it out now, right? By being able to mine through all this data we have, we can go back in time and figure out that this route flap happened because of this port that went down, and or potentially nothing had happened, everything was working fine, and maybe you have an IP table rule in your VM, or maybe you rebooted your VM, whatever, right? Maybe the fault is somewhere else. But it allows you to go and debug the network, right? So what we're doing here is mostly a debugging tool, I think, more than anything else, to allow you to figure out what is going on in the network after the fact, right? More than anything else.
So that correlation engine, that's quite sophisticated. Is that would you call that a big data app? Or?
I hesitate to call it big data because people want to put behind big data large Hadoop clusters and stuff like that. It's not actually using large Hadoop clusters. It's using a regular SQL database behind it. Yep. But you can think of it as big data if you want to.
It's not that big at the end of the day. A data center is just not that vast. Exactly. It's fairly simple, right? You've got a couple of hundred devices, or maybe even a couple of thousand devices. There's not that many. It's not.
Right. It's something very doable, right? And it's all about building the algorithms to do these correlations, right? And allow people to visualize the correlations.
I guess my point is, one of the things that I keep talking about when I'm talking to people is the fact that software is now able to do stuff we couldn't do 5 years ago. Yes. There's two things here. One is we've got new algorithms, new ways of approaching calculating correlations that we never had before. And two, the machines that they run on have got vastly more compute power and memory than we've ever had before. And it's not hard. So this is something we've always talked about doing in the past. We've had any sort of fault managers and correlation tools that they never worked. But now we have. Or is that fair? Is there something? It
is fair to a certain extent, although I must admit something. As everything we do in Nuage, we build on the shoulders of giants. A lot of the stuff, a lot of the core components of our monitoring and correlation engine are actually components that have been running in service provider networks for the last 4 or 5 years. So we grab these components, repurpose them, right, the core engines, and reapply them in new technologies. But a lot of them have their inheritance, if you want, yes, in large service provider networks. What technology allows us to do now is exactly that. It's the same thing that people are talking about disruption, right? Something that was available to very few and very expensive, it can run now very small and very good, and it can become available to everybody, right? That's what the software allows us to do right now.
Yeah. I guess there's two parts to this. There's a lot of data there in a sense, but you've got to filter out a lot of non-relevant. So it's quite a complex process. You've got to, is an LSA4 update actually relevant? Or is it just, is it a root flap or whatever? There's a lot of room in there for, say, less than perfect coding. Yes. For there to be bugs to creep in, and you start putting your trust in these systems. How do you handle that? So
we have some capabilities in there to allow the user to kind of create triggers and triggers that make sense to the user. So, for example, you can create triggers that events from these BGP route targets are more interesting to me than other events, right? Or events that show high utilization in a particular interface are more interesting to me than other events that show whatever, right? So you can program the systems. Now, so it's not like, let's put it this way, it's not an easy button that you put it out there and it will solve all your problems because it's going to do magic. In some cases, you have to tune it based on your needs and what is interesting to you. But there are a lot of options to tune it, right? There is a lot of flexibility built in the tools to be able to do that.
I always get a little nervous around flexibility because it can also mean, like, not nervous, but, you know, a little bit, you know, approach with caution, proven testing. You know, I'm looking for predictable stuff these days, not, you know, eventual convergence isn't what I want. I want predictable convergence, like predictable outcomes.
Right. So for what we are doing is for the data center applications, we have packaged it in a way that it's pretty much, you know, offered as is without the knobs. If you are a very advanced user, though, the knobs are there, right?
Yeah, you can still fit. Yeah, in the data center, it's actually not that complex, so it's fairly easy to tighten it down. In the WAN, it gets a bit more complicated. Yeah.
So is this a standalone product? Can it be deployed without the virtual network solution from Nuage?
So no, I'll describe this how it works. It is actually it needs to correlate to a network virtualization part, right? It's part of its job is to figure out the overlay networks, and the way it interfaces right now, it interfaces and discovers the virtual network topology out of Nuage. However, and I will go a little bit on that, is the same way it uses BGP to monitor the underlying topology, it uses BGP to monitor the overlay networks as well. So it doesn't only get the events and the monitoring and the flapping of the underlay, but it uses BGP VPN essentially to listen to the overlay events and monitor these events as well, right? So that's part of the correlation engine. So it has these two components that we discussed, right? The route monitor and the correlation engine. And route monitor is all standard protocols. Correlation engine is where I would say is most of the intelligence. And the other part, and we will see some of this hopefully, is that in some cases it will provide a suggestion. And it will provide a suggestion, if you want to fix this problem, do this. Now, again, it is a suggestion. I don't want to advertise it as, you know, we can turn it to an automatic go fix the problem, because I don't think without a human being in the middle, the problem can be automatically fixed. But it will provide a suggestion, go look there, kind of thing, right? So don't get lost, go look there.
Is it pluggable though? So that way, hypothetically, you know, could you know, if there was a hybrid deployment with Nuage and another vendor?
I mean, at this point, we haven't done this yet. It's something that we will consider doing, right? But if, for example, you have a deployment that uses BGP VPN, and there are some vendors, right? So, you know, that deploy even their data center products deploy based on BGP VPN, right? So there is Cisco, there is, I think even Juniper has a product, right? So in these instances, we will recover the service topology by using a BGP, right? Not by using any other API, right? So for the vendors that have converged around BGP VPN, we can actually do that.
Did you say that one of the inputs beyond the routing protocols is also L2 topology stuff?
L2 topology is limited to, you know, this interface has the subnet behind it, this particular physical interface, you know, 225 on the top of rack switch has the subnet behind it. We don't have much visibility behind, right? So if this subnet has 10 switches underneath there running spanning tree, we just see one big subnet, right?
I mean, a large spanning tree topology doesn't make sense with your overlay.
Right. I mean, the whole idea of deploying overlays is to move to layer 3 topologies to begin with, right? So that's where we believe we are trying to solve the problem. From an architecture perspective, right, there is the basic platform capability, and the basic platform capability has the routing protocols, an SNMP agent, a REST API agent, the route analytics and correlation engines. And then we have written a whole bunch of web applications on top, if you want, that allow this visualization of the data on a consumable way by a human being, right? Because you can always dig through the APIs and stuff like that. But we wrote a couple of applications on top, like an inventory management application that is kind of a map. I have this here, I have that here, and how they relate. There is a service management component that shows these are the services, and this service belongs on this physical node, this other service on this physical node. And there is the fault management component that does this correlation of events to figure out what is happening in the background and what happened in the past and how the events are correlated with each other.
Have you thought about, just curious, using Open Daylight as the platform? Because some of the southbound protocols, you know, were there in terms of BGP or SNMP versus building it all in-house.
Right.
And writing the
So-
apps on top.
We would use that if we would start from scratch, but we didn't really start from scratch, as I said. A lot of the route analytics and correlation engines are from our service provider products.
Okay.
They are very mature platforms, so it didn't make sense for us to start from scratch.
And this platform itself has open APIs itself as well.
So I've been talking about some of these capabilities, right? So I talked about the policy correlation. The policy correlation essentially says that we are tracking what is happening on the VSD part. And we will see some examples during the demo. The monitoring and troubleshooting is things like historical events, what happened last night, alarm correlation that I defined, the impact analysis, we talked about it. And then we actually do something interesting that I didn't realize it was happening until we saw it happening, right? VMs come and go, and you have a VM, it's running, and then you destroy it, and then the UUID of the VM gets destroyed, so you lose track of it. So you actually need to maintain these virtual objects even after they disappear, right? You have this problem that because VMs come and go, you know, the user, for example, can start a VM, it didn't work for him, the network was not working, he gets panicked, destroys the VM, starts a new one, and then you're trying to figure out what happened, right? So you need to really try to understand the history of what was happening in the back.
So this is all, you know, extracting data, right, with these protocols. So, you know, is the next step to, you know, push back down to the physical? Because obviously if you're speaking BGP, you can actually have another impact on the network in terms of redirecting.
So this is a leap of faith, though, right? At the same time, it's a dangerous thing because it will take some time. I think let's put it this way, the vision or the final goal, right, in the perfect world is to reach that state. The reality is that operations people tend to be very conservative, and they will say, you know, if trusting a tool to dynamic create a feedback loop, it will take some time. Right? They will be.
Well, the reason we use overlays is to get away from fiddling with the physical network. So producing a product that configures both is kind of not what you want. You want to say, you know, I think that it's the sales thing. Yeah.
At the same time, you want to give the visibility. I want to give enough visibility to the operations guys to notice that, okay, there is congestion here or there is something bad happening here that I can go.
It's a mean time to innocence play. If something happens, it's not you. It's the physical network. I can point the finger at the physical network. Yes.
It is also this, right? It is part of the equation, right?
Yeah. How real time is this? Because I'm seeing historical and root cause of previous events. Are we at the proactive side of I can send you effectively kind of a root cause event and here's what it affects?
Right. So the loop, depending on how it's configured, but the loop right now, you can assume that getting a VM down event, it's almost instantaneous, it's within seconds. Getting a BGP event, right? It's gonna dampen it. So I think right now the timers are you're gonna get it within 60 seconds to 120 seconds. Right, so it's going to aggregate the events, and you're going to get the alarm, the red thing blipping in your eyes within 120 seconds, within 2 minutes. Right, that is not real time, but it's real time enough, right, for a lot of things.
Okay, and for what it is correlated, how's that? Is that part of that alarm? Is okay? This BGP route's disappeared.
Yes.
Been out for 2 minutes. Here's a link to, or here are the things that are down as a result of that.
Yes.
Because that's almost the fault management.
Yes.
This is the great trap management problem, right? Is I suddenly can't poll 3,000 things because a WAN link went down.
Right.
I don't want 3,000 alerts. I want one that says the WAN link went down. By the way, here's what it affected.
Yes.
Yeah. So the tool has a lot of this trap dampening. You know, if you get a lot of events, essentially event storms, dampening down the event storms, and you will see in the demo that we're going to do is that when you get the event, you can immediately get the correlation that because of this event, all these other guys are affected right now, right? So I'll give an example actually of that.
Yeah, and that actually led me to the same question that was asked earlier about, so can it run without the virtualization part? Because it's like, well, that's actually kind of useful. Put aside the virtualization. So this is kind of handy.
Exactly.
Extend that down to layer 2, MAC address to IP mapping, so you know what switch is, what's on what switch port, and you got a handy network management tool, and you're into another line of business.
So, you know, the correlation is needed if you want to see the overlays working with it. If you don't, and you will see in some of the examples, it's just an underlay network monitoring infrastructure, right? So it does that. I'll show you the examples where it correlates some things. So,
Good ones are them too,
Right,
quite
right.
honestly.
Is there an API or something so that you can tie into like change control and ITIL and these kind of things where some work's going to be done in a cabinet? What are the dependencies and who are we going to impact?
yeah, so there is an API for the tool, and there is an API available, and it can be provided, and it's pretty much a standard type of API that any OSS tool or whatever operations tool on the top can talk to this and recover the data, right? It's not just a web interface, let's put it this way.
Can you like subscribe to events as well, that kind of thing too?
Yeah, you can subscribe to events and get the alerts and all these things. So some of the examples that we can talk about now of how the platform works is, and we're going to do some screenshots here first, is, we have an example here of the platform discovering a physical topology and then overlaying with another color the virtual topology, all the upstream routers, or being able to discover to identify exactly the basic statistics of every node, right? Another example, this comes back to the fault correlation that we'll see it in action as well, is that we detected an upstream router that actually has withdrawn a prefix. As a result of this prefix, we know that the virtual switch is down. As a result of the virtual switch down, we know that a bunch of virtual machines down, and we know exactly which ports are down, and we know which services are down, right? And this is a visualization that is created automatically through the fault management tool. This is an inventory type of application that shows that I have the data center. The data center has these controllers, and the controllers, I organize the servers in these groups, and every group has vSwitches and virtual machines, right? So you get the tree view, and you can drill down to figure out what is happening. A very important thing is, and that is what we are demonstrating, and we showed in ONUG, that's how we managed to pass the last two tests of the ONUG use case. Is actually, it's a completely multi-vendor solution. So we're actually demonstrating that the solution together with Arista switches. So some of the switches are Arista switches, some of the switches are actually the Nuage gateways, some other are Alcatel-Lucent routers. It can pretty much work with any third-party switch. Is not limited to our physical infrastructure, right? Because there is nothing proprietary in running routing protocols. We also have some proactive monitoring tools. So we have, for example, a tool that you can go and pick two virtual machines and create a continuity test from the underlying hypervisors, right? So the one vSwitch is going to start talking to the other vSwitch to prove that these virtual machines are supposed to be talking to each other. So maybe there is an IP table rule in the virtual machine that is actually breaking connectivity right now, right? So we have this type of probes that allow you to start doing pings if you want and trace the overlay that is actually working. Last but not least, for our branch locations and our branch product, we have added an agent in our branch product that collects all this information and allows even more correlation with this tool. So it will allow essentially our branch offer to figure out whether the branch is rightly connected to the right overlays and what is the relationship between this branch and the overlay networks that we have created on the wide area network in this case.